On where you are. Good evening, good afternoon, wherever you are in the world, and welcome to the Nordic Express. I will, for 1 hour, take you on a brief train ride and trying to give you a notion on systems engineering as a practice. So let's start with a brief introduction of myself. My name is Christopher Fröling, and I'm working for the reuse company. And I have some slides at the end showing what we are doing. But basically, I'm working as a system engineering professional, both as an application engineer in the tooling side and as a system engineer and trainer when it comes to teach people in system engineering practices or in writing requirements. And I've been doing that for 20 plus years now. So this is the train. And you can imagine that we are sitting on this train. We are leaning back in the seats, enjoying the view and looking forward to getting to the point where we are interested in getting off. But suddenly something happens. So what happened? Why did the train stop? And many things will start to go on in the train and between the different people on the train. We start to getting worried. Is it serious? What has caused the stop? Is it a technical problem? How long will it take for us to be here? And perhaps is it an accident? Is something seriously going on? There are many things that can go wrong actually with the train, as you probably know. And when we try to define what's going on in a train or what capabilities a train should have, we usually use system engineering practices. And basically what we say then is, from a system engineering point of view, is that we need to manage, in this case, the passenger's expectations. Of course, something shouldn't go wrong, but if something do go wrong, what can we expect, and how should the train and the train system be able to manage that? So all these questions should turn into some answers, and at the end of the day, those answers should be able to be managed within the technical system we have defined. And for instance, if we don't think that the train yet has been caused to stop, we could think that a regular passenger, he or she, they want to be able to be 15 minutes before the train departs on the platform. And the train should then be there. And then we have to think as a system engineer, is this feasible? How much will it cost to have all these trains running into the platforms? Will it be worthwhile to do so? And if the answer is no, there's no obstacles in this. From a system engineering perspective, we always say that we first define the problem, then we're trying to define the solution for the problem. And that's a very iterative process. And to be able to build a complex system like a train, we need to have technical requirements. And one technical requirement supplying a solution for the passenger expectation in this case could be that the train shall be able to depart from the platform, or should be at the departure platform 15 minutes before the departure time. That sounds quite reasonable. And of course, we have other types of requirements. There should be enough room for everyone to allocate their luggage. That's perfectly reasonable expectation. And then we have to think, okay, if we then have a lot of passengers, how much luggage can we think that these people will bring onto the train? And how will we be able to manage that? We need to do some serious calculations and expectations and do a model on how these things will be. And on the technical side, there will probably be a lot of different requirements managing this. Both technical requirements on what we call is quality, where, for instance, security, usability, and these things are regarded as quality aspects. And then there will be operational requirements, other types of requirements which are related to cost and timing and such. So this very quickly turns into a huge set of requirements. That's typically how we do things. Of course, these days, many companies have started to model different viewpoints of a train. So we can model, for instance, some technical aspects, but we can't model everything. So we are very often set with a set of technical requirements or other requirements in language form like this. Another requirements, is it cold? Okay, we have to consider the context, not only the function. The train has to run somewhere. How cold is it? How can we measure the temperature? And by doing so, we have to allocate resources that can do that job. And in this case, we have to check the temperature range within the area we are supplying the train. And if we don't have any problem with that, we can then turn those expectations or those answers, which are basically technical decisions, into technical requirements, because we don't have the solution yet, but we can define it in an early stage. So if you think on the requirements workplace as a Christmas tree, you start with the goal as the star. You need to supply this transportation, and then you bring it down to needs that turns into requirements, that turns into detailed requirements and design requirements. So this means that we have to manage complexity. We have to manage risks, and also we will not probably do everything ourselves, so we need to manage responsibility. And of course, we will, when we define the solution, also manage to describe why we are doing it in a certain way, because we need to be sure that we can design and deliver an efficient solution that properly solves the need at the end of the day. So when thinking about complex systems, there's a complete field within systems engineering and system thinking, which is managing complexity. And there are some different definitions, and I don't have time to go through those, but basically there's a couple of different versions of complex systems. The first you can call a complex spaghetti system, which is really independent things which are connected together. And I would say that today's transportation system is a spaghetti system. It's a different layers of trains, tracks, signaling systems, platforms, ticketing systems, and so on and so forth. And they are, even if they are connected together, they are not designed together. So it's independent system communicating with each other. Then you can come to multi-level behavior systems, which is also a train system as such, where you define how the train system is supposed to be. But when you break down these definitions, they are starting to conflict with each other. So one decision at one end will for sure make other systems less or more efficient. And more systems are computer-based, and more systems are using artificial intelligence and neural networks and machine learning as such. So systems will more and more learn how to behave and react. And for instance, financial systems are absolute memory systems that for sure memorize what's happening from 1 millisecond to the next. And if we consider that a train system is a complex system, we have to manage risks, because we will have uncertainty over this, not over the train ride as such, but on the ride to develop this train system. So how can we manage these things? One thing is to look into the requirement side as such. And those of you that has experience in writing requirements, you perhaps know that requirements should be They should follow a SMART paradigm. They should be specific, they should be measurable, they should be acceptable, they should be realistic, and they should be traced to the source. And that's rather an old paradigm. And if you know about the INCOSE Guide to Write Requirements, INCOSE is the organization working with systems engineering. They have developed a guideline. They talk rather about correctness, consistency, and completeness, where correctness is for one requirement. You should be able to state if that requirement is correct or not, while consistency and completeness regards a set of requirements. And I will talk more about that throughout this presentation. So some examples. If you don't manage this kind of risks, this kind of flaws you have in your set of requirements, you will find overlapping requirements. And the process itself starts with overlapping interests, for sure. You can think yourself that different stakeholders, different people with interest in what you're doing, they will have different views on what's important and how the need should be described. So you will have contradictions that you have to work with in the first place. And here are some examples. If we have written these set of requirements based on our discussions with our stakeholders, for instance, the train shall be able to depart, again, the train shall be at the departure platform 15 minutes before the departure time. Okay, fine. To fit in all the suitcases, the train attendees is allowed to move the suitcases along the wagon, which means that we don't have any restrictions for how to operate the luggage. Then we have another requirement. The train attendee shall check the temperature inside the wagon 5 minutes before departure. And now we can check every requirement one at a time, saying this one is correct, this one is correct, this one is correct. But what happens if we start to compare them together? The first ones, they are absolutely independent. But when you start to look into the third one, you start to realize that how can the train attendee both move suitcases and check the temperature? Perhaps that's not possible because you check temperature at one end at the train and you work with luggage throughout the train. So perhaps that's not possible. So here you can have an inherent lack of consistency. And the solution would be to change the requirements. Of course, you don't want to have that requirement still in their set of requirements, because that means that you will have a train with certain technical capabilities, and you will have different work practices which will not be coherent with the solution. So you have to change it. Either you start to check the temperature 5 minutes after departure, meaning that the train might be cold when you start, or hot, or that you actually can do it before you start to move the luggage. So both these are when you start to look into the working practice of the train, the attendee of the train, you find out that you have to manage the technical aspects in two different ways. So overlapping requirements, they can either be the same requirements saying completely different things, or they can have contradictions in the meaning of the requirements. You can also have different measurement units, which actually happens when you have global organizations using both inch and centimeters in different parts of the system that can cause catastrophic events. And you have to be able to control the value range that is put into the set of requirements themselves. Are they technically feasible? Can you afford that kind of solution? So there are many things to think about. Another thing is to start to think on what you actually are doing when you state the requirements. You're not doing it for yourself, you're doing it for somebody else. And if you talk about the train wagon, for instance, be sure that it's called train wagon everywhere, and you don't change the meaning of that term, or you change to another term stating exactly the same object. So you have to be very precise on the vocabulary. Another thing is when you write requirements is to be clear on the structure. You didn't think about that probably in my examples, so they were quite simple. But you should think basically, this is an example of subject, action, object, which is, you could call, if you Google EARS, easy access to requirement structure, you find that you should think in a specific way when you write requirements. Subjects means that there's somebody doing something, either a person or object. Action is what's happened, and that action happens to the object or for the object. You will see that in an example. And if you don't follow these things, you start to behave wrongly when you state requirements. For instance, writing passive voice, which I will show you now. So if you look into these two examples, the train attendee shall check the temperature inside the wagon 5 minutes after departure. Or the temperature shall be checked inside the wagon 5 minutes after departure. Both looks as perfectly fine technical requirements, right? But if you think on this again, where you have the subject, action, object, if you write what we call passive voice requirements, you can actually leave out the subject, meaning that the solution for these requirements, you can't control it. It can be whatever, as long as you are checking the temperature, but you're not stating who. In this case, it's the train attendee. So it's very important also to keep aligned with the structure. And this is quite common when you talk to each other, that you use passive voice, because you know the context, you know what you're talking about. But when it comes to requirements, you have to be much more strict. So you should have an acceptable vocabulary. You should have a clear structure, and that proper grammatical structure can also mean, if you know how requirements should look like, you can also create solutions to check if the structure is correct, that you don't what we call what is called false friends, where you actually think that you have a meaning of the requirement, but it's actually something completely different. But I wouldn't go into details. Again, the Guide to Write Requirements has 40+ different rules for stating a good requirements, alongside a requirement is correct, and a set of requirements should be consistent and complete. And again, going back, in order to manage completeness, you have to take into account all the stakeholder views, even if they have different views. And there are different practices, how you manage expectations, how you use different techniques to filter out the true meaning on what you think is the system of interest, so you can write the proper requirements and so on and so forth. But we don't have time to talk about this. But if you haven't got in touch with systems engineering yet, please start to look into that. It's a fascinating subject that can really help you achieve your goals. And when you start to define both the problem as such and then the solution for that problem, you have to create what we call meaningful relationships. If you think that A is dependent on B, or for instance, you can say that A is doing something to B, if it's a functional requirement, it should be meaningful. You have to have a strict control on the context itself, otherwise it might lose sense. And to do so, we usually use models. And this is a very simple model taken from one of our tools, where you have defined that you have a train, and the train have different stakeholders, and the stakeholders can be of 4 different types. And the wagon, again, has different parts in it. And of course, this is an oversimplification just to show you how things are. And the meaning of this is to be able to control what you write requirements on. If you're trying to write the technical requirement for a piece of equipment inside the wagon, you had better make sure that it's also part of your information model. So everything has a meaningful relationship. We will not talk more about modeling, but there are some pretty good modeling practices that can also make complexity less complex. So you have to include all stakeholder views. You have to create those meaningful relationships. And you also have to think, when you look into the risk parts of this, what is the things that you don't want to see, not only the things that you want to see. So this is when you start to look into risks related to security and safety, for instance. What are the things that you don't want to see, and how should you make sure that the work practices or the technical system corresponds to that? And if I work as a systems engineer in the project, where does the responsibility ends? It looks like it never ends, right? The thing to do is to, first of all, consider it as a black box. I'm not sure if you have heard about the black box description, but basically it's, think of it, a system as I said, a box. And the meaning of black means that you shouldn't open it if you don't have to. You should look at it from the outside, trying to define the problem and the solution from that viewpoint. And then you hand over that box and with your information to the next level, where you decompose things and you start to develop more and more details, and you take design decisions along the way. So you have to be very strict on the boundaries of your system. How tight should you define your system? Is it a small system? Is it a large system? How to communicate between the different stakeholders, how to manage complexity. We don't want to have a spaghetti system, but sometimes we need to integrate to something which is already there, which means that we have a constraint on what we can do. How will we manage that? We also need to think that there will be independent functionalities which are within the system, which we perhaps don't have to define right now, because we can define it from the outside, that we really don't care at this point in time how you do it, as long as the response from the system is as we want it. So we have to look at both demands and behaviors of the system itself. And of course, it relates to capacity. And I guess that if you work with human-centric design and your areas of expertise, here is where you have to consider the human part of the system. Many times the humans are the weak point in the system. So you have to design a system that corresponds to human nature, human needs, and not the other way around. So it will force a constraints for us technicians. An unwanted situation and unneeded behaviors or unintended behaviors are very much connected to the area of system safety. So you have to be sure that if something happens which you don't want to happen, that you can return your system in a safe way. So I embrace very much the notion on collaborative and effort. And as a systems engineer, I know that I don't know everything, and I love to invite people which are good at specialty engineering disciplines like human factors engineering, system safety, system security, logistics, and so on and so forth. They are always part of my teams. And in order to manage uncertainty and these behavioral constraints, you need to define use cases. How is the system intended to be used, or how is it intended to be abused? And what is the cause and effect of this? And how can you manage the technical aspects from those? And if you're working with software, you have probably heard about user stories and epics and things like that. And that's how you can more precisely describe the interaction between the human part and the technical system as such. And for this train, it will be a complex system and it will be a complex solution. It's hard to see a train without signaling system, without an electrical system, without tracks, without platforms, without ticketing systems, so on and so forth. So it will be a complex system. So you need to define these levels of system engineering practices so you can manage these things. And of course, many things can happen. You have to think about the traffic distribution as such. How will you manage both the physical movement of trains and how will you manage the data around those trains? And again, how can you manage the different aspects that different technical functions bring into this solution? It tracks, it's signaling. What happens if you have a new constraint on a new EU regulation for some new signaling system standards, and you start to redevelop, redesign in one end, buying new things, upgrading old things, you will end up with different levels of uncertainty how these things will behave in your system. So of course, standardization is a must, but it's a very slow system to standardize. And in the meantime, if this ever gets perfectly standardized, in the meantime, you have to manage these uncertainties for sure. And again, ticketing purchase is probably ruled by the different countries as such. You have different currencies, you have different ways of how you order tickets. And in these days, we would like to be able to buy a ticket in Stockholm, where I live, and perhaps you want to get off in Bad Gastein in Austria, which is actually what I did. And besides being a nightmare for buying tickets, it was, well, we can take that another time, but it wasn't a smooth train ride, as to be honest. So there are constraints. How can we manage those? And how can we make sure that, again, the human in the system gets value for money at the end? What is quality, to be honest? So we need to make sure that we can collaborate, okay? And when we talk about these huge technical projects, like building a new train system, we are probably looking into many thousands of requirements. And we have to have practices to make sure that they are clear, they are understandable, and they, by all means, they need to be feasible, okay? And there are two different ways. Either you think that they should be vague, because I shouldn't, as a system engineer, restrict you as the designer. I write a need and you answer back with a requirement. That will mean that I will leave the uncertainty until I know your answer, or I can start to do the design, and I can be more strict, saying that the system has these parts, and these parts should behave in a certain way. Then I turn it over to the next level. What is right and what is wrong, I can't really say that, because it depends. So that leaves us to the development practice as such. And you have probably heard about lean production or lean development, which is basically a Scrum based thing where you have iterations in software, versus more structural techniques where you have waterfall practices, where you plan first, you allocate resources, you define the problem, you write requirements, and it sounds very strict. And my meaning of this is really that you should think of it as a collaboration. You need to have structure and order, but you need to be more easygoing. You need to be more agile and more interactive with your set of stakeholders. So I think these two practices should be more brought together, to be honest. So when we set up a way of working with a customer or organization, we need to be very, very flexible, and we need to have our ears to the track, really listen to how we can set up this iterative working environment that has enough control to manage basically the risk. That's all we want to do. So it's quite hard to take these standardized system engineering lifecycle management processes like ISO 15288 or ISO 29148 for requirements management and say you should do it like this. They all need tailorization, and again, these practices don't really cover for specialty engineering practices, like, for instance, human-centric engineering and human design. So there's a lot of work, hopefully, going on within those communities to fine-tune these sets of practices, so they really can work together. So basically, what I wanted to give you are some key takeaways. We need to identify the inefficiencies when we do this, which basically mean that we need to find what's in between the lines. It's not enough to review requirement specifications with 500 requirements. You will not find all of these inefficiencies. You will not find the incompleteness, and you will not find the inconsistencies. That's super hard to find. So you need to have more modern working tools that guides you. But you can't forget that you have to remember that someone is always responsible, meaning that you have to bear in mind who has written this requirement, who has had the need in the first place, so that you can understand how to validate your requirement or set of requirements, so that you can say at the end of the day that, yes, this is good, this will work, or at least I think this will work, until I'm proven something else. And a hard thing is to level out how much control you need to have. How controllable should your process be? Should it be very lean and very agile, meaning that you will build a lot of prototypes, you will do a lot of customer testing, and you will get feedback, and eventually you will have a good system that will probably not work when we work with safety and security related systems, where you need to be able to show through traceability that you have not built a system which is potentially unsafe. So how much level of control do you need? Too much will restrict everything and just bear a lot of documentation and administration, and too less will mean that you increase the risk of something going on, you increase the uncertainty, and perhaps you create a system that a third-party organization will say, no, you cannot prove without reasonable doubt that this is a safe system, so you can't use it, even if it does what it's supposed to do. So that's control versus controllable. But again, you have to manage and be aware of you can't control everything. So you have to embrace that there are things which are uncontrollable, and that things will happen. And I'm usually saying in this sense that you should always have a tight team that talk a lot to each other. You should do a lot of things in a team setting, which of course can be hard if you have a large team sitting in multiple time zones with multiple languages and so on and so forth, but you have to try. And again, even if me as an engineer, I love having a fun day at work, meaning that I love inventing new stuff, solving old problems in new ways, and so on and so forth. We need to manage the constraints, which are often that the system needs to be safe. It needs to be user-friendly. Sorry for calling that a constraint. It needs to apply to certain levels of work practices or standards or whatever, which really limit the solution space. And I need to embrace that. I need to say that, fine, this is what I have to live with and apply to. And that was basically the end of this very short and brief presentation. Before I take some quick questions from you guys, I would just like to mention that we at the Reuse company, we are working a lot with different R&D organizations and also different groups to establish a better way of working with complex systems. And we come from the tooling side, and one complexity that we see within many organizations are that they have a siloed view on engineering data. So you have requirements in one side, you have some models, perhaps you have some human-centric design or some systems doing prototyping, and these don't really talk to each other. They don't exchange data, they can't communicate. You can't manage complexity by looking at the different pieces. So we are heavily involved in the different inclusive working groups, mainly right now in the product data working group, and also in the requirements working group. And the drivers for this is, of course, complex systems, complex security-dependent systems like aerospace, defense, automotive, and energy sectors. Now, our goal is to improve and facilitate the SE process as much as we can. For instance, by having these kind of seminars for you guys, hopefully inspiring you to do something different tomorrow. Stop doing something bad and start doing something good. Even if this was a very, very broad and quick presentation of one view on SE from a train window. And by doing so, we are offering a set of tools that will manage information and knowledge so that we can have one single synchronized source of truth within the project. We need to manage traceability so we can make sure that we are solving the right problem in the right way. Quality management, what is a good requirement? What is a good model? If you can define that, we can also make sure that all requirements are complete, correct, and consistent. And we can add inline authoring that helps you on the way while you have defined these quality rules. And don't forget that you don't have to have tools to start doing this journey, but it will for sure help you. But don't run off buying different tools if you don't have the problem defined yet. So start in the right spot. So that was a very quick presentation. I understand that I've been doing this a bit quicker than my colleague Katarina that presented this the last time, but hopefully I've been able to tell you some interesting viewpoints on systems engineering. So do we have some questions from you? You can either use the chat if you want. I see that Elena has done so. Is this a question to me and to everyone, I guess? Human factors engineering professionals participate into system design or concept level or design level. From my viewpoint, I hope that you that work with human-centric engineering, human-centric design, that you are part of the complete train ride. You should be part of the team from the beginning, being able to present your view on the problem at hand, so that you can start to define and perhaps constrain some engineers from doing some bad decisions in the first place. And I would love to integrate human-centric top-level requirements from the start in my projects, so I know what are the goals here. Defining the different stakeholders, the different users, the different customers, defining their personas, so that we at the end of the day can deliver systems that cater for different types of users, for instance, people with disabilities, for instance. I'm not sure if I answer your question, but if you start by defining that you have different roles, then you can start to define how will that affect the design as a concept, and then for sure define the proper solution at the end of the day. Do we have any other questions from the audience? We also have a question and answer function, and I don't think that anyone has written anything there yet. No. From my side, it's I hope that you start to look more into systems engineering if you haven't done that yet. If you Google INCOSE, you will get into the INCOSE community, and I know that there are working groups within INCOSE looking into the usability of systems. So I hope and guess that you are part of those, some of you at least. But if we don't have any other questions, I would suggest that we end this presentation. You can always email me afterwards if you have some more thoughts, and the presentation as such I will provide to you, so you can distribute it as well. So thank you very much for inviting me, and good luck with the human-centric endeavor in the regards of whatever system you are trying to build. So good luck, and hope to see you somewhere out there. Bye-bye.